Hello, everyone. Can you hear me? Can you hear me now? Okay, cool. So I was saying hi. Thank you for joining. Um, let's wait for maybe like 2 more minutes. So everyone that wants to join has joined, and then we'll start. Let me know if you can see my messages before. The link to the slides and also the notebook. If not, I'll send it again. Okay, chill. Okay, that's great. Okay. So, in case you don't know me, hi. My name is Negar. I'm based in Turkey right now. I'm a master's student. I'm studying computer science, and my focus is quantum computing. I used to be a machine learning engineer for like 4 years, And now I'm kind of changing lanes. So yeah, let me know where you're from, where you're based in the chat. Okay, from India. Very nice. New York. A chemist. Cool. France, Canada. Damn, okay, international. International people. And Kuwait. Very cool. So I think we can start. Yeah, let's start. So since a lot of people in this club are beginners, I thought today we're gonna have like a lecture type. So I'll just give you like an overview of the stuff that you need to know for classification, and then we'll get to coding. I have 5 notebooks ready. They're like they're short, don't worry. But I don't think we get to like finish all of them. Let's aim for 2 notebooks and just finishing up the slides. And then we're gonna have another session next week where we just like I mean, I don't like talk much. We'll just get to actually like building a project. So let's get started. Okay. So let's first start with what classification actually is and what is like supervised versus unsupervised learning. So these two are different methods of teaching a machine how to give you predictions. Supervised methods are labeled data, and unsupervised methods use unlabeled data. So let's see what a prediction is. In a prediction, you basically guess a value. Um, for example, we can predict someone's age. We can predict like based on their facial features, or you can predict whether someone is a good student or not based on their previous grades, if they take notes or not, stuff like that. So there are different kinds, and you need some prior information to be able to guess these values, right? So let's like go through a legit example. We have Felix here, a distinguished data scientist. So he wants to build an Apple predictor. So he builds this neural network or a machine or whatever you want to call it, a model. And he wants to say, hey, this is an apple, or no, this is not an apple. Okay. So we get an input, and the output would be no, right? So it's a binary situation here. Like, this is not. Just a second. Please keep yourselves muted. Thank you. Okay. So in this case, this is a pear. This is not an apple. As easy as that. That's a model right there, and that is classification. And we call the input feature or features if it's like more than one. And the label is yes or no, or the value, whatever value that you're trying to predict. And the two main ways to predict something are regression and classification. So if you have numerical values, like let's say the age example that I just gave you, or like stock market predictions, that's numerical variables, right? That is called a regression task. And categorical variables, like is this an apple or not? I'm not audible. This is weird. Can you hear me now? Okay, this is so weird. Does this keep getting turned off? Okay, sorry. So where did I lose you? So I was just saying, like, let's just look at a very simple classification example here. Given a number of miles, we would like to predict if I would walk them or not. Like, would I walk 1,457 miles? Okay. And we're trying to predict a binary categorical label, yes or no. So we need some prior data here, right? We know, like, for example, that I would walk like 5 miles or 4 miles or 10 miles. So we need to kind of have a bunch of data here. And also we need to think, okay, like maybe I should set a boundary here. That's the first thought, right? So when I put the data here, it looks like this. And there's a clear line here, right? And since we used labels here, because there was a feature and then a label, then this is a supervised learning algorithm. So when you're trying to predict something and it has labels, it's called a supervised learning algorithm. And you're trying to model the relationship between a feature, the features and the models, the features and the labels. And you can clearly see that you can separate this data set here. So it's perfect. That's just a very simple example. Now, so you know what classification is right now, and you know what regression is. For now, let's just focus on classification. Like, for example, here, you can see that actually you can have multi-class classification. Like, it doesn't have to be binary. We have like 1, 2, 3 classes here. And it's a 2D multi-class classification. And it can like go up to way more than 3. It can be like 10, which is like a very difficult task to do. Okay, that's classification. I hope you kind of have an idea now, theoretically. Now, what is Pytorch exactly? Does anyone know what Pytorch is? Have you worked with Pytorch ever? Or maybe TensorFlow at all? Alrighty, okay. Yeah, it's a Python library. Okay. Okay, 10 minutes. That's still good. Okay, so to kind of do any machine learning or deep learning task, you can't do everything by yourself, right? Like, imagine like writing all the functions by yourself and trying to optimize them. That is insane. So there are some very famous frameworks, or as do you call it, library or module, whatever you want to call it. We call them frameworks. And of course, they're all in Python. And let's see what they are. I actually did a course with Real Python about this. So let me just show you what they are. Wait, let's start from maybe 5. Okay, so let's start with Pytorch. Okay. So it's obviously named from Pi plus Torch. It's developed by Facebook AI Research Lab. Well, now it's called Meta, but before it was Facebook AI Research Lab. And Pytorch is more the research tool, but it was especially actually designed for research, like research in machine learning, because it's very Pythonic. So it's like kind of, well, I mean, it is Pythonic, and it's very easy to use and implement. So you can like build multiple models and try them out at the same time. So it was mostly popular in research, but nowadays actually like it's pretty popular even in production. Still, like other libraries like TensorFlow have an edge, but Pytorch is pretty popular, especially like in startups. And yeah, it's almost as popular as TensorFlow as of 2023. And well, now it's 2024, so it's even more popular now. This is the tools that developers use in general. The most popular one is .NET, believe it or not. And you can see here that 8.37%, 8% of developers prefer scikit-learn, which is you probably have heard of this one. It's a very popular machine learning tool. And TensorFlow is on top here by not that much difference. And then you have Pytorch, Torch and Pytorch. So it's a pretty good tool. It's coming around. So Pytorch is based on Torch, which is a framework for doing fast computation, and it's actually written in C. So when you run Pytorch, you're actually running, C. And it also has a Lua wrapper for constructing models. You don't have to know what Lua is. Just know that that's how it's working. And the reason that it's really popular in research is one of the reasons that it's running C and you're actually interacting with it using Pytorch, using Python. And so a really important feature of Pytorch is that it really manages memory really well. And it has a lot of optimization methods that you don't need to actually configure yourself. It kind of figures it out for you, which gives you an edge compared to other tools like TensorFlow. And also, I don't know if you guys know other coding languages like C or JavaScript or something like that. You know that error messages can be a pain in the butt, right? You have no idea what's happening based on an error message. But in Pytorch, and well, in Python, but Pytorch specifically, you get more sensible error messages. So when you're doing something wrong, you know exactly what's wrong. And yeah, it's more transparent. It's an open source model, so you can kind of know how everything is done. And I mean, I don't know if you guys know about NumPy and Pandas, which are two main Python libraries. And well, NumPy is mostly for like mathematical stuff, for matrices, like dealing with them, and Pandas is for handling like tabular data, like CSVs. And Pytorch is pretty chill with NumPy and Pandas. This is just an example to see kind of the contextual, like how the language looks like, and this is how it looks like. It's pretty Pythonic, right? Like you're multiplying stuff, you're calling NumPy directly from Pytorch without, any hassle. So, and you also have TensorFlow. Let me go back. So it comes from Tensor plus Flow. Tensors are basically like boxes of numbers. Let's call it that. They're basically boxes of numbers that's both TensorFlow and Pytorch deal with them. Like that's their building block. That's how they understand data. So it's developed by Google Brain, and it was released as an open source library in 2015. And this is how it looks like. As you can see, kind of it's not, especially here in the results line, you can kind of see that it's not as readable as Pytorch. This is a very small example. So just to give you a sense of the code style. And yeah, that's just the two libraries that you really need to know. So TensorFlow and Pytorch, and you're going to be dealing with Pytorch today. And I'm just going to give you an example of what it looks like. So this is a blog I wrote, and it's how to build an autoencoder. And here I'm building a neural network. Okay, so Pytorch is built on classes, Python classes. So I built like my own custom neural network here. I called it autoencoder. And as you can see, like I don't have to really define what a sequential is here. In case you're new to like neural networks, sequentials are basically like the layers of your model that you're building. Okay, so you have like an input, you do stuff with the input to make it more sense to the model, and then you have an output layer, right? So this is how you built them using Pytorch, and this is like 3 layers here, and it's only a few lines of code. So this is our goal, to kind of be able to build stuff from ground up like this. You don't have to really understand this. I just want to show you what it would look like. And yeah, that's about that. Let me know if you have any questions. Hello. So before we get into coding, please let me know if you have any questions. And then we'll open the notebooks here. And by the way, you don't need to have anything installed. Like you just have to like open with, and then it gives you a Google collaboratory option. So when you press it, NN is neural network. But yeah, PyTorch uses NNs for like neural network features that it has built in and you can use. Okay, so you should see something like this when you open the first notebook. Oh, and how many of you have Codecademy Plus? So I just know. Okay, cool. Okay, okay, I got it. So here you go. This is what we're gonna work on. Let me get the actual link. I think it's this. Okay, so this is the course we're gonna focus on. And in case you have Pro, you can literally just code along as I'm going through the lessons. Or you can, if you don't have Pro, that's okay. Just go through the link that I sent before, the Google Drive, and open the first notebook. I'm going to give you like maybe 2 minutes to kind of get ready. Okay, perfect. Let's wait for others. And let me send you the link. Yeah, so in case you're interested in knowing more about PyTorch and TensorFlow and what's used for what and stuff like that, I wrote this article. Well, I contributed to this article, so you can check it out. Okay. I'll be back in like 2 minutes just to give you guys enough time. Okay, I'm back. So what's everyone's main programming language? Yeah, Python for me as well. What about everyone else? I'm working with Julia nowadays, and it's like a pretty cool language as well. Yeah, it does say intro to Pytorch, but I already have done Pytorch, intro to Pytorch events before, so I figured I do this one now. Elixir. Amazing. I'm really meaning to learn. I would like to learn, what is it? Go as well. I think it looks really cool as well. It's just whenever you see someone that's like a pro Go developer, they have aged. Like you can see like the pain in their eyes. Okay, so let me just. Okay, so the goal of the entire lesson here is to try and predict. It says it here, right? No, it doesn't say here. So you basically want to try and predict this data set here. Let me send it to you. So you want to predict the where is it? You can actually do a lot of things with this data set. You can predict their, like, based on students' education and like their sex, their age, their scholarship type, blah blah blah. You can predict a lot of things. Like for example, you can predict if they would get a scholarship. You can predict their grades, their education level, like whatever that you would like, or like even the amount of the scholarship that they would receive. So the lesson's ultimate goal is to be able to predict stuff from this, like based on this. And but we're not gonna start dealing with the real shit from the beginning, and we're gonna go very slow, and we're gonna cover encodings, sigmoids and thresholds, and if we have time, we're gonna dabble like into binary cross entropy loss, which is probably gonna be the most like math you're gonna encounter in the entire lesson. Okay, so let me just go through this. Let's go through this together. So we already know that we're dealing with categorical values, which are our labels. And here we have a bunch of IDs, like student IDs. We have their high school type, and we have letter grades from A to F, and their outcome, like did they pass, did they fail, and that is the outcome here is what we're trying to predict, okay, what we're trying to classify. And to do that, you need to first encode your data in a way that your model actually understands, right? And to do that, you have two options. You either have label encoding, and you use that when you have only two options, like 0 or 1, or you have a definitive amount, like you have 0 to 4, like for the grades, for example. And you have hot encoding. If you've like done natural language processing before, this might seem familiar to you. If not, don't worry, we'll get to it. Okay, so for label encoding, for example, it's usually better for the model to receive numerical values instead of strings, because like pass and fail doesn't really mean anything to a machine, right? So you change them into numbers. Like pass would be 1 and fail would be 0. That's literally called an encoding. And in case you're unfamiliar with pandas, don't worry. DF stands for data frame. And pandas, I mean, I explained before, it's like a library that lets you deal with annoying like data sets, or just any data sets, but especially like really annoying data sets. Pandas helps you to kind of deal with them. And you don't cry. So yeah, so df is data frame, and the outcome is the column in the data set that you're choosing, and you're saying, hey, everything that's in the outcome, I want to replace them. When it's passed, I want it to be 1, and failed 0. It's pretty, I think, straightforward. Now these are meaningful for your model, and you can also do this with the letter grades, right? So A is 4, B is 3. It's kind of like a GPA. C is 2, D is 1, and F is 0. It's exactly the same syntax. You're choosing the letter grade column, which is here, right? You're selecting this column and then changing the stuff in it by using replace. Okay, now, so this was what you had before. This is the original column. And now after you encoded your labels, this is what you get. So you have a bunch of student IDs, the letter grade, and then the outcome, which is either pass or fail. Okay, any questions so far? Okay, cool. So one-hot encoding is basically when you have too many options in your column. Like, for example, for this column, like state, private, and other. And I mean, this is only 3, but sometimes you have, like, for example, imagine like the English alphabet and all the words in it. Like, you can't just be like, oh, 1, 2, 3, and then, you know, just name all the letters. That doesn't make any sense. So what you do is do one-hot encoding. So instead of replacing categories with numbers, we'll create a new binary column for each category. So here you have ID, high school type, and one-hot encoding is basically like you're creating one column for state, one column for private, and one for other. Okay, so if it's like, let's say like for, it's here. So for this example, student 1 has a state high school. Okay, so the type it's state. So you put 0 for everything else, and you put 1 for state. You do the same for every other student. So private, you put 0 for state, 0 for other, private, and eventually, if it's other, you put 0 for others and other options, and then for the other column, you put 1. So you can literally like do this by hand. So Pandas is very generous here, and it gives you a method that you can use to automate one-hot encoding. And the syntax is basically saying, okay, so get the use the get dummies on my data frame. And then you're like, okay, which columns do I do this? You select your column. You can literally do more than one. But here we just want to do a high school type. And then the D type is like, what type of encoding do you want to do? You can do floats. You can do integers. And here, because it doesn't, it doesn't really make sense to do float, let's just do integers. And that's it. So this is how we're going to do one-hot encoding. And that's all you need to know. To wrap up, you understood label encoding. It makes sense if you have like 2 options, sometimes 3 options even, but in this case, we're trying to simplify stuff. And if you have too many options in one column, you do one-hot encoding. Okay, now let's look at the notebook. And see what exactly we have to do here. Yeah, and I forgot to actually explain what a Jupyter notebook is. So I'm sure most of you guys have worked with like VS Code or any other like Pytorch, like code editors, right? And you might even have seen notebooks before. You can literally run a Jupyter notebook on VS Code or whatever else. But usually we prefer either internal Jupyter notebooks or running them on Colab, Google Colab. Anyhow, Jupyter notebooks are mainly used. Yes, Anaconda. Thank you for reminding me. Yes, yeah, you can do it. You can actually install Jupyter notebooks via Anaconda or Pip, whichever that you're more comfortable with. Which I think Pip is probably better if you have some coding experience. Anyhow, so Jupyter notebooks are they consist of textual stuff that you can write, like taking notes or explaining your code. And you also can run whatever code that you want. You can store audio messages, you can store audio files, images, almost any sort of data that you'd like for data science. The good thing about Jupyter is that it not only works with Python, it also works with Julia. In case you don't know, Julia is like it's not an emerging language, but it's starting to emerge like in popular data science projects nowadays because it's really fast and it's easy to understand and it's fast. That's the main point. Like compared to Python, is pretty fast. And you can here like choose the kernel that you want. I don't think you're gonna need it anyway, but yeah, that's just good to know that it's a very complete tool in data science. Okay, enough me talking. So in checkpoint here, we have to first import pandas. It's the library that I talked about before. Usually, like we gave it an alias called PD. It's just a convention. Okay. And make sure that sometimes in Codecademy, like the Jupyter doesn't work. So if it doesn't for you, either like press this reset workspace thing if it doesn't work for you, or just refresh your browser. Okay. Now we're just loading the data here. We're not actually using the legit data set here because it kind of is a little bit messy. So we're not doing that. Codecademy is giving us this data frame and the label encodings we discussed before. And then df.head just gives you like the first 5 items in your data set. So let's do that. Okay. So this is what you get: student ID, letter grade, and outcome. So it worked. You already know this so far. And you're doing so you did letter grade here and also the outcome for label encoding. And now you're doing one hot. Is this filled up or let me just, no, it's not. Okay, cool. And this is one hot encoding, right? You already know how to do this. We saw it before. You're just running it here. And then you get high school type, other, private, and then state. Okay, nothing new here. And you also have these other information about your data set: additional work, regular, artistic, or sports, and whether this student has a partner or not. Okay? So we're adding all this data. Now, just a second. Yeah, so what you have to do here is encode these new columns that you created. It shouldn't be hard, right? These are like just yes and no. So you need, I'll let you decide. Okay, let's take 5 minutes here. And please don't just see the answer, because I know you can just like do it wrong and then. get the answer. Just like try to actually think about it. I'll see you in 5 minutes. When you're done, just like write in the chat that I'm done or I have a question. Ooh, fast. Nice. Let's wait a little bit more. While we're waiting, I saw that Anwar is here and you have a label here that you won. What was it? The global world coding games winner. So congratulations. That's really awesome. You have a cool badge and everything. Okay, so which encoding did you choose here? Yeah, so you're using the first encoding, right? So let's do that together. So because you're doing like 3 columns here, it's best to create like a variable called binary columns. And let's just copy their names and put them in a Python list. And has partner. Okay. And then we'll loop through the columns and then encode them, right? So for column in binary columns, and the data frame, find that column and then change it. So if it's yes, it'll be equal to 1, and then change no to 0. Okay, let's run this. And of course it works. You have additional work, whatever, and you have zeros and ones. Okay, cool. Now the last checkpoint here is the MT1 preparation. It contains categorical data on how students have prepared for the final midterm of the course. Students may have either prepared alone, with friends, or not applicable if they didn't prepare at all. So we need to, of course, use the one hot encode method here. So let's do that. I'll give you a little bit of time and then we'll do it together. When you're done, just tell me, or if you have questions. So we're doing the hello. Okay, so we have 3 notebooks here. Wait, let me show you. So in notebooks, you don't have to like install anything. You press on these 3 dots, open with, and you should see Google Collaboratory. And if you don't see this, you can either just open Google, like collab.google.com, or you can add or connect more apps to your Google Drive. I suggest that you actually connect Google Colab to your drive. Is this the this is the link for Colab. Okay, anyone done? Anyone ready to do this? Okay. Let's go full screen. So 1 hot columns. You only have 1, but it's just good practice to have this. MT1 preparation. Am I spelling it right? I can just copy it. And then you're just saying get PD, pandas, use the get dummies method on DF, specifically on 1 hot columns. And the D type is, of course, an integer because you don't need floats here. And that's it. And it works because you have 3 separate columns here. Okay, that was encodings. I think we have time to go through sigmoids and thresholds. If you have any questions, let me know. Yeah, we can use the melt function. Okay. Or actually, maybe we don't do this today. Let's just go through the theory, okay? I'll give you like a little time to, I think some of you are still trying to do the exercise, so take your time. We're not in a hurry at all. I'm going to go on. Okay, so in neural networks, I kind of mentioned it before. So you have an input layer, which is your features, is the data that you're giving to your model. And then you have to do something with these inputs because you're trying to model your data in a way to like generalize it so you can predict stuff from it, right? So what you do is you introduce some weights for your data. And you might be like from where am I supposed to find these weights? So actually the model does it for you. Like for example, Pytorch and TensorFlow have ways, like they have prepared methods, different mathematical equations that will find the best weights that will generalize your model and actually create a model, create like a linear or maybe it's not linear relationship between your data. They find that. Okay. So, but for now, we're not like really focusing on how that happens. We're just focusing that it does happen. Okay. So you have a bunch of input layers. Like, for example, if this person studies, which is 1 if they do, 0 if they don't, and whether they take notes or not. So if they take notes, it's 1. If they don't, it's 0. Okay. So that's the input layer that we're focusing on right now. And we introduced some weights here by ourselves. And you might be like, why is it 2.5 and like 5 here? It's just random. Usually, actually, that's how you start the process of finding weights. You initialize by finding some random numbers. Here, we're actually giving more weight to notes and like half of that weight to studies. That's how we're starting. Okay. You're giving it some weights and then you're putting both of them to output layer. And the output, what is the output, is whether the student will fail or pass. If they pass, it's 1. If they fail, it's 0. Okay. Okay. So what we're doing is, well, whatever the input is, we're multiplying it by 2.0. And if it's studies and for notes, we're multiplying it by 5. And then we're putting both of these things into the output layer. So in our case, this is just an example. This person studies and doesn't take note. Okay. So 2.5 times 1 and 5 times 0, and you put both of them together to the output layer, and 2.5 plus 0 is 2.5. So the output layer will give you 2.5. And you might be like, hey, Liz, yeah, I got a value. But what the hell does 2.5 even mean? It doesn't mean anything. We're supposed to get either 0 or 1. So what the hell happened here? This happens like all the time when you get a number that is not between 0 and 1 in classification. So what the hell do? You use sigmoid activation functions. This is the equation for it. It's 1 over 1 plus e to the power of minus x. And basically what it does, this is what it looks like, right? So whatever you give this function, it will put it between 0 and 1. You see the range here? Like from minus infinity to plus infinity, whatever you give it, it will be between 0 and 1. That is exactly what we need here. And thankfully, we can implement this very easily, right? So, and for example, if we put 2.5 and you feed it to the sigmoid function, you get somewhere really close to 1, which makes sense, right? Because this person will, I mean, if you study, you will pass probably. So you're very close to 1 here. You get like 9.2, like something. So it's very close to 10, to 1. So you're adding one more layer to your neural network. From your output layer, whatever that it is in your output layer, you will feed it to a sigmoid function. And then what you get from the sigmoid function, that is your answer. So how do we actually, let's go ahead and we have time. So let's go ahead and implement the sigmoid function. You actually have it here. You don't have to do anything. You're importing the math module to be able to use the E number here. So let's just run it. And here we're literally just coding what you just went through now. So you're first defining your inputs. This person studies, doesn't take notes. And 2.5 is the initial weight for studies. 5 is for notes. And here you're summing up these two weighted studies and notes, and then you'll print them, and then you're applying the sigmoid function on this weighted sum that you like just created here. Yeah. So this far, this is how you code. Okay. If you have any questions, please let me know. I'm reading the chat as we speak, so just let me know. Okay. So you get a number here, right? And in our case, it's very close to 1. But then you have to have a threshold to actually say, okay, like if it's I don't know, above 0.6, then I'll say, okay, this is a 1, this is a pass. And if it's below 0.6, then it's probably, this person is probably going to fail, because we want to, it's a binary classification, right? So that's actually, that's all threshold is. Usually, like in simple examples, you put it into 0.5. So if it's 50% or more, you're like, hell yeah, this person is going to pass. If it's less, sorry, no. But in more sensitive situations, like in medical examinations or anything related to medicine, really, when you need to be really precise, well, this is not just the threshold, but usually it's higher. Usually it's like around 0.6, somewhere there. And of course, there are other factors you have to put into for precision. Anyway, so this is how you compute the threshold. You're like, if it's if the probability that you're getting is above threshold, then it's like it's true, so you'll get a 1. If not, you'll get a 0. And this is what you're doing here, right? And you're creating an integer out of it. Let's just run this code and see what happens. And yeah, nothing major here. Your classification is 1 because we're very close to 1. Okay, that's great. And our time is up, so I'm going to stop here. You now understand what a sigmoid function is, what a threshold is. The only thing left here for you to do is actually implement it here. So for the studies, for the GPA, like just introduce the stuff that's given to you here. And yeah, I think we covered everything. So you can do this task and this task right here. And maybe this will be a little bit tricky to you, but we kind of covered it in the beginning. So I think you can figure it out. Plus here, there's a whole section. Where is it? Is it here? Oh yeah, here. This is a very good read as well to help you understand the third checkpoint. Okay, I think I'm going to stop here. And we will continue this. Really? Oh, I'm so happy. I was just about to ask. So I have been organizing events for about 4 years now, and I went from online to in person to online, and now still online. And usually I do like advanced topics, but I've noticed that in Codecademy, you guys want me to do things that are for beginners, because nowadays everything is so complicated everywhere, right? So yeah, let me know if this was too slow for you. Was it the right pace? Just give me feedback on the pace of what you learned today. I don't believe in having more than an hour of events, because I noticed that, even I can't stand events more than 1 hour. So I don't want to do too much, like do 2 hours or an hour and a half, unless it's like really necessary. Okay. Oh my God, amazing. Oh my God, it's 5 a.m. Where are you based? Oh, Colombia. Okay, I see. I'll try to find a way that it makes sense for the that continent as well, for the American continent. So let me think about it. Thank you for the feedback. I'll try to. Is Saturdays okay for you? Does the day work? I'm asking everyone, by the way. The Saturdays. Thank you, guys. Okay, so Saturdays are okay. I'll just need to like maybe adjust the time a little bit so more people can come. Okay, awesome. Thank you, guys. I'll see you next week. I'll post an event with the new timing, but it's gonna be next Saturday, and we're gonna finish this lesson. And we're gonna probably have time to even finish a project, like a very small project that's here. I'm not sharing my screen, but it's predicting hotel booking cancellations, which is in Codecademy. So probably we'll do that together next session. So thank you, and you can Amina, you can exercise in Codecademy, like do the exercises in Codecademy, and also in the like in case you don't have Codecademy Pro, you can just use the notebooks that is provided in the Google Drive link that I sent you guys. See you guys. Thank you for coming.